Welcome 8th grade to 8-2 Notes Video 1, Adding and Subtracting Rational Expressions. These problems are going to require a little more work compared to Lesson 8-1. Just like anytime you need to add or subtract fractions, you have to have common denominators first. So to start off, we're going to get comfortable with finding least common multiples, which will allow us to be able to find least common denominators. Least common denominators are just the least common multiples of the denominators. I have a note here, just like in 8-1, you want to factor first. Anytime you're asked to find least common multiples, least common denominators, or if you want to add, subtract, multiply, or divide, you factor everything that you can. But we're going to start off a little simpler with just properties of exponents. Now, some people reached out and said they weren't quite clear on what I was highlighting and what my notes meant. So I'm going to walk you through this approach. There's also an alternate approach to finding least common multiples of different expressions that I'll show you as well. So we'll start here with this first approach that the book shows you. And what they do is they list out all the factors of each expression. And we do what's called prime factorization with the coefficients. So for 12, we don't want to think of 12 as either 4 or 3 or 6 and 2, because that's not going to quite break up the numbers enough for us to be able to pick out common multiples. So instead we do prime factorization. So break it up as far as you can. We don't need to include any times 1 because that would be pointless. So we break it apart as 2 times 2 times 3. 15 is the same thing as 3 times 5. And 8 can be broken all the way down to 2 times 2 times 2. And then you'll notice all the variables are just listed, the number of times that the exponent tells us to. Okay, so what I have highlighted here, to find the least common multiple, you want to use each factor the greatest number of times it appears as a factor. So I'm seeing, if I focus just on my coefficients, I'm seeing 2s, 3s, and 5s. So I want to list the 2s, the 3s, and the 5s the most number of times that I see them within the expression. So in my first expression, I have 2 2s, but in my bottom expression, I have 3. So that's the most. So my least common multiple is going to include 3 of the 2s. Okay, for the factor of 3, at most I see it only once. So I only need it once in my least common multiple. And same with the 5s. At most I only see it once, so that's why the 5's included. Okay, for the variables, you just want to keep in mind the least common multiple of the variables is always the largest exponent given. So if we were to come up here and compare, your a has the highest exponent of being squared, so a squared. Your b has the highest exponent of b cubed, and your c has the highest exponent of to the 4th. So that's where it becomes part of your answer. A different approach for the coefficients that I added to the notes a couple days later. What you could do instead is list all the multiples rather than all of the prime factors. So I just started by doing all multiples of 12, and I got as many as I thought I would need. Then I started going with 15 until I found the first multiple that they had in common. And then I need to also make sure 8 works with that value, which it does. So that's the other way that you can approach least common multiples, actually listing out all the multiples and finding the first one they have in common. Okay, that one's usually easier for students to understand, but then often students complain that it does require a little more work because you're listing so many numbers. So get to whatever comfort level you need to. Just remember, no matter which approach you take with the coefficients, the variables are always going to be the largest exponent. Okay, guided practice 1 part B. This one's different. It's not properties of exponents, it's properties of trinomials. So we want to start by factoring. We always want to start by factoring. The first expression here has a 4 that we can take out. And now we just are left with factors of -4 that add to -3, which would be -4 and a +1. The second expression, we have an a in common that we can take out. And now we're left with factors of 20 that add to -9 are -5 and -4. So I factored completely. Now, it's the same idea. I want to use each factor the greatest number of times that it appears as a factor. Okay, so that's what I've highlighted here. Another way that you can think of this is, what does each expression have that the other does not, and you need to include all of those pieces. So I have a coefficient of 4, I have a factor of a, and notice both expressions have a factor of a minus 4. In order for this to truly be the least common multiple, since it only appears once at most in each expression, I only need it once in my least common multiple. And then I have an a plus 5 and an a plus 1 and an a minus 5. So you're going to include every single piece, every single factor that you have, but you don't want to repeat factors. Like in this case, we don't want to put a minus 4 twice, because that's just going to require more work in the end. You can use it to find common denominators. It's not truly the least common denominator, but it's going to require more work in the last step. Okay, so hopefully that clears up a little bit with finding least common